Hello and welcome to a binary search algorithm tutorial. I'm going to show you a binary search algorithm, a very straightforward, simple one. First, let's talk about the purpose of binary search. Binary search is an alternative to brute force. Brute force searches through a list, iterating through each element from start to finish until it finds one. So let's make an array here. A list of integers, and let's just give some values, and they have to be in order. If I want to search for the number 7, it'll start at the beginning and search each element until it finds the number 7. Then when it finds it, it'll return true, for example. Now, if I have a binary search, it'll start in the middle. If on a sorted list, if it's bigger, it'll take the second half, it's go to the middle there, and then if it's bigger, it'll go to the second, it'll go to the last half, or the half of in between the original middle mark and the second middle mark. So basically, it goes from 50% point to 75% point. Then if it's lower, it'll go to the 62.5% point, and then lower, like for here, it'll start at about 5 and then go to 7. It'll find out about the second iteration. So binary search. First thing, in order to use binary search, it has to work on a sorted list. So the first thing you have to do is sort the list. Otherwise, binary search is pointless. So now that we have a list that's sorted, let's go ahead and make the binary search algorithm. I'm going to make a private static Boolean binary search. It's going to take an integer array and an integer for what you're searching for. Now I'm going to say the first array element is 0. The last is the length of the array minus 1. And the middle is the first plus the last divided by 2. Now you want to do a loop here. You want to say while first is smaller than or equal to last, and just go to this loop until you find the element. If array middle is smaller than search, if the middle element is smaller than the search, then you want to say the first is now middle plus 1. You're going to search to the second half. Else, if array middle equals search, then you found it and you want to return true. Otherwise, the only other option is that it's bigger. So you're going to say last equals middle minus 1. So the first stays at 0, or wherever the first is at from a previous iteration through the loop. And the last is now what the middle was minus 1. It'll search through the first half. Then after these if statements, you want to reset the middle to first plus last divided by 2. And it'll search through, and you want to return false if it hasn't found it. So this algorithm, if it finds it, it'll return true. If it doesn't find it, it'll return false. So let's go ahead and say if binary search list 7 system.out.println found 7. If binary search list 12, actually I should say if not binary search list 12, out.println did not find 12. If this algorithm is working right, it'll display found 7 and did not find 12. So let's see what happens. Yep, it did. Found 7, did not find 12. So binary search is really necessary, especially when you have large lists. It's something idea that's used in a lot of programs. Who knows, Google search might use something like that. Dictionaries, thesauruses may use binary searches. It's something important to know. It's an important concept to know as a computer programmer. But be sure to know you have to sort the list first. A binary search on an unsorted list is completely pointless. A list that's unsorted, you just use a regular bubble sort for a small list, or if it's a very large list, quick sort is probably more effective. So a very large list, quick sort and binary search will probably be the most effective way to go. It's all a case-by-case basis, but that about wraps up the video. Thank you for watching. Hope you have a great day.